In this video, we're going to look at solving linear systems graphically. So when two or more equations are used to solve a problem, we call this a system of equations. If all the equations are linear, this is called a linear system. And that is what we're going to look at today, is solving a linear system of equations. How do you know if a relationship is linear? Well, here are two examples of linear equations. 4x plus 5y minus 6 equals 0. That is your linear equation in standard form. And y equals negative 2x plus 3. That's a linear equation in slope y-intercept form. And we know these are linear equations because the exponent on the variables x and y are exactly 1. In our first example, we're going to solve the following linear system graphically. When solving a linear system graphically, here are 5 steps. First step, choose the best method to graph each equation. So you either use the slope y-intercept method or the x and y-intercept method. Next, graph both equations using the methods of choice. Label the graph and the lines. Fourth step, determine the point of intersection. And the final step, verify that this is the correct solution to the linear system. So let's look at our first linear system. So let's start by using both methods for graphing. So let's take the first equation here, x plus 2y equals 4, and I'm going to use the x and y-intercept method. So that means if I'm looking for the x-intercept, I'm going to let y equal 0. And if y equals 0, I get x plus 2 times 0 equals 4, and therefore x equals 4. So there's my first intercept, and it is 4 and 0. Next, I want to look for the y-intercept. And to find the y-intercept, I'm going to let x equal 0. So that gives me 0 plus 2y equals 4. Therefore, 2y equals 4. And y would have to equal 2. So I have a y-intercept of 0 and 2. We plot that. And then we can connect the 2 points with a straight line. So I'm going to call that equation A, and I'm going to label that as A. For the second equation, y equals x minus 1, recall that we have a slope and a y-intercept. The y-intercept for this equation is going to be 0 and negative 1. That is this part of the equation. And the slope for this equation is going to be 1. And since it's the number 1, that's 1 over 1. So a rise of 1 and a run of 1. And that is given by the constant or the coefficient in front of the x in this equation. So next step is to graph this line. So starting with the y-intercept at negative 1, then we're going to go up 1 and over 1, up 1 and to the right 1. And if we want to do one more, there we go. There's the second graph B. I've labeled my lines to tell which one is which. I have labeled my x and y axis with the corresponding scales. I can include a y and an x, so we know which one is which. And now we're on to step 4, determine the point of intersection. And looking right here at the graph, we can see that the two lines meet at the point 2 and 1. So let's conclude. So therefore, the point of intersection, or the solution to this system, is 2 and 1. If you don't want to write that all out, you can say therefore xy equals 2 and 1. Your choice. The final step is to verify your work, and this will check that you've done everything correctly. So let's start by looking at this point and its relationship between these two lines. So to verify, we're going to set up what are called t-charts. And in the t-charts, you're going to put equation A, which was x plus 2y, and on the right side of that equation was 4. And then over here, we're going to put equation B, which is y and x minus 1. Now, using the point 2 and 1, we're going to verify that these equations work. So I'm going to sub in 2 for x and 1 for y. And I get 2 plus 2 times 1, which is 4. So 4 equals 4. So that is correct. Now let's sub in the point here. 1 goes in for y. 2 minus 1, because the x was 2. We get 1 equals 1. So therefore, we have verified that the point 2, 1 satisfies the two equations we have here. So let's try this one more time. Starting with the first equation. It's already in slope y-intercept form. So let's start there. We see the y-intercept here is 0 and negative 3. That's given by the negative 3 here. And we see that the slope of this line is equal to negative 1 over 3. That's given by the coefficient in front of the x. So with this line, we're going to start down here at negative 3. And then since there's a negative in the top, we're going to go down 1 and to the right 3 to get the next point. So let's do that twice. And there is our first equation. If I want, I can go to the left 3 and up 1. If I want to go to the left of that intercept. So there is line A. Now let's look at line B. Let's use the intercept method again. So if I want the x-intercept, I'm going to let y equals 0. And if y equals 0, I get x minus 0 equals 7. X equals 7. So I have 7 and 0 for the x-intercept. Next is the y-intercept. So I'm going to let x equals 0. So I'm going to get So I'm going to get 0 minus y equals 7. Don't forget there's a minus y there. So we get minus y equals 7. Divide both sides by negative 1, and we get y equals negative 7. Because remember, we want to solve for a positive y. So here we get 0 and negative 7. So let's graph these two. So we have 7 and 0 way over here. 0, negative 7. And then if we draw a line through these 2 points, there is the point of intersection. We'll call this equation B. I already have my numbers on my axes, but don't forget to label your axes, x and y. Now we can state our point of intersection. We can see it intersects right there. And that is the point. We count over 1, 2, 3, down 4. That is the point 3, negative 4. So let's conclude. Therefore, xy equals 3, negative 4. But don't forget, we need to verify that this is all correct. So let's do our last step. So we're going to draw out our t-charts. So for the first one, we have y on the left side. And if you look at equation A, it's negative 1/3 x minus 3. Equation B is x minus 7 equals x minus y equals 7. Using our point 3, negative 4, let's see if this works. Negative 4 goes in for y. Then we get negative 1/3 times 3 minus 3. So let's check to see what happens. Remember, this is the same thing as 3 over 1. So we have Negative 1 times 3, so we get negative 3 over 3 minus 3. 3 over 3 is 1, so we get negative 1 minus 3, which is negative 4. That works. And again, if you can do this in fewer steps, great. Next is x minus y, so x is 3 minus a negative 4. So that's 3 plus 4, which is 7, and that works. So therefore, this is the point of intersection, or the solution to the system of these equations given here. All right, one different example before we're done for today. Determine if the ordered pair xy equals 6, 2 is a solution to the system. This one you don't need to graph. So think about this for a moment. Pause the video and see if you can find out if this point is indeed the point of intersection or the solution to this system here. So again, you have been given the point of intersection. So if you want to check if it's a solution to the system, you could graph it. But the quickest way is just to verify. Is just to set up your two t-charts and see if this point works. So I have x plus 2y for my first equation equals 10. 3x minus 2y equals 10. Well, let's see what happens. If I put 6 in for x, I get 6 plus 2 times 2. 6 plus 4, that's 10. So it does work for this one. Let's try the other one. 3 times 6 minus 2 times 2. So that is going to be 18 minus 4, 14. 14 does not equal 10. So this is not a point on that line. So the point 6, 2 is only on the first line and not on the second line. So this is not a solution to the system because it must be a point on both lines. So we can say therefore xy equals 6, 2 is not a solution. A solution to what? To the given system. Here are some questions from your book that you should try. And for those who want a challenge, I want you to tell me the value of a given that the graphs 2x plus 4y equals 10, 4x minus y equals 11, and 3x plus ay equals 14 all intersect at the same point. So what a value will make this true? So there's the a value there. I've even given you the answer, so if you've done this all correctly, you should get an a value equal to 5. Try it. Tell me how you would solve this problem.